We're going to take a brief look at the average value of a function. And the average value of a function can be thought of as the average height of a function. So if we take a look at this diagram here, that blue function f of x has an average value or average height where I've drawn that yellow line. And we can see that between a and b, the points a and b, so between those two bounds, the yellow line represents an average value or an average height. And we can kind of estimate that by looking at the little bit of the blue function that's above that yellow line, which I've drawn in red, and a little bit of that function below the yellow line, which I've kind of shaded in blue. And if those are roughly equivalent, we know that that yellow line should represent the average height. Okay, so we do have a formula though to calculate this average value or the average height, and it's based on the area from A to B under f of x. So if we take a look at this, if we take the area from A to B under the graph of f of x, if we take that area and we divide it by the interval from A to B, or in this case B minus A, if we divide it by the interval b minus a, or the length, we're going to end up with the height of that rectangle. And so all we're doing is, for this formula, is we're taking the area, we're dividing it by the length, and we're getting the average height of the function between those 2 points a and b. So how do we apply this? So looking at the average value of cosine of x. So here on the right-hand side, I have the cosine of x, and we want the average height of that function from a starting point of 0, so this starting point here, to 2/3, which is this point here. Okay, so we want to take this area and we want to work out the average height based on that area. So we're going to take, if we want to kind of estimate that, we can kind of see that we're going to take away some area here. Just going to do this one. We can say that those two areas kind of cancel out. If we take that green area and stretch it out over that interval, maybe that kind of would represent the average height along that red line. Okay, so let's work this out. So first of all, I'm going to take use my formula here. So I'm going to take the average value of f of x, or the average height. This is the average, is going to be equal to, and I'm going to start with my interval, so 1 over b minus a, so my end point is 2/3, my start point is 0, so it's going to be 2 pi over 3 in the denominator, and then we're going to integrate that function from 0 to 2 pi over 3 cosine x. Okay, working that out, I'm going to end up with the coefficient is going to be 3 over 2 pi. Okay, that represents the interval width. The actual area is going to work out to be sine of x, and we're going to integrate that or use the bounds from 0 to 2 pi over 3. So that's what my area is going to look like. Plugging that in, I end up with 3 over 2 pi sine of 2 pi over 3. Sine of 2 pi over 3, that's 60 degrees, so that's going to be root 3 over 2. And then sine 0 is 0. So when I work out that value, it's going to be 3 over 2 pi, and it's going to be root 3 over 2 minus 0. So simplifying this, I end up with 3 root 3 over 4 pi. And that's approximately equal to, when I work out the decimal value, of 0.413 approximately. And if I take a look at this graph here, Yeah, at about 0.413, if I stretch it out to 2 pi over 3, that area above here, I'm just going to shade it, this area above the line is roughly matching the area below that line. And so that line at 0.413 represents my average height or my average value. So we can do the same thing here for x squared. Okay, I'm going to set it up first. So my average value is going to be based on the interval width, or 1 over 0 to 5. So it's going to be 5 minus 0. And the area underneath the function x squared from 0 to 5. So this is going to represent the average height of that function. Okay, so taking a look at my graph here, if I look at the area underneath this graph, so looking at the area up to here, this area underneath represents the area that I'm going to use in the formula. And we're going to see some average height, and I'm just going to kind of estimate it here. I'm going to estimate the average height to be, roughly somewhere around here, where the area above that yellow line and the area below that yellow line is roughly equal. So in integrating this then, I end up with 1 over 5, the integral of x cubed over 3, and evaluating that from 0 to 5. This works out to be 1 over 5, 125 over 3 minus 0. Simplifying that, we get 25 over 3, which is my average height. Okay, so that represents the average height. So this height in here is going to be about 25 over 3, or roughly about 8.3 repeating. That looks about right, and it looks like that area above here roughly matches the area below the yellow line. That's not part of the area under that curve. So lastly here, we have the average value of the function f of x equals tan x. Now, and this is from pi over 4, negative pi over 4, to pi over 4 here. So I'm looking at those bounds, and when I try to work this out, so the average value is going to be equal to 1 over, the interval width is going to be pi over 2, and the bounds are going to be from negative pi over 4 to positive pi over 4 of tan x dx. Now, we run into a problem here in that we can't integrate this at this point. So I'm going to just say can't integrate yet. Okay, there is an integral for that, but we haven't learned how to integrate that yet. So this could be a problem. However, if I actually take a look at the area here, because of the symmetry of the graph, and it's important because of the symmetry of the graph. If I take a look at the area underneath this graph, from negative pi over 4 to 0, and the area from 0 to pi over 4, they are equal and they're going to cancel out. So because of the symmetry, although I can't actually work out the antiderivative for this, I know the integral is equal to 0. So I know that this portion is equal to 0, and I know that 2 pi, or 2 over pi times 0 is going to be equal to 0. So the average height is going to be 0. So that means that, yeah, it looks like it balances out. The average value of tan from negative pi over 4 to pi over 4, because they balance out due to symmetry, is going to be equal to 0.